Okay, hello everyone. So we are back with another session of with a new session of microcontrollers and embedded system BCO601. So I'm just going to show you the syllabus right here. Yes, so see, you just have 9 topics in this to study, and we can recollect a few topics from the digital design and computer organization subject, which comes in your third semester or fourth one of the semesters. In that, there are a few topics you can take over here, like about instructions, registers, and pipelining and stuff. So the first topic is quite simple. That is design philosophy. We'll be talking about what it is, what are its more fair. Four major regions, and we'll just compare it with CISC. Okay, so before we start about RISC design philosophy, we'll have to do an introduction to ARM embedded system. So it's just like I have highlighted a few things which will help you to remember, like ARM processor core is widely used in 32-bit embedded system. So you have to always remember this 32-bit thing. Later we will be talking about, like 16, 32, 64, or also sometimes like supercomputer stuff, but that will be in third or fourth module, not now. So here they are just telling like when was the first ARM prototype developed and why it was successful. See, a simple but powerful design. So we have to remember this, that the ARM processor, that RISC and all, it has to be simple but also a powerful design. And here continues tech innovation, a family processor design with a common instruction. Family processor design in the sense, we'll be talking about microcontroller and microprocessor and all. Microcontroller, like a chip has everything and all stuff like that, example and all stuff. So we'll just start with the topic, the RISC design philosophy. RISC, RISC. So we have to like know the full form of the reduced instruction set computer. So always remember what is RISC. You just have to remember the first term. R means reduced. Few people get confused it as registers. It's not register, it's reduced. So like less, it's less, like reduced, got less, something like that. RISC and CISC. See, only R changes, right? Reduced and complex, if I'm not wrong. See, so what is RISC? It is nothing but a design philosophy. So see, the RISC design philosophy is nothing but the RISC is in the space you have to put here. See, you can see here, right? Let me just draw. In this space, you just have to write is a design philosophy. Why it is a design philosophy, and what type of design, why it is like made a design philosophy is because it is aimed at improving processor efficiency. So always remember which efficiency. Every time it is designed, whatever is designed, until and unless it's the first time, or to say innovated, the second time if it is upgraded or enhanced, updated, it's the only reason. I mean, the only reason is because you have to improve something, like the flaws from the previous model, something like that. So here what they are improving is nothing but the efficiency of the processor, mainly by two ways: one, simpler instructions, and two, higher clock speed. Simple instruction is nothing. See, you have to remember this clock speeds. Clock speed is nothing but the time taken, for one instruction to complete, like that. So you have to make simple instructions which are executed very fast within a clock cycle. So that higher clock speed, in the sense the time taken should be less. For example, if an instruction higher clock speed, in the sense the time taken to complete for instruction is too high. So that is for better performance executed in one clock cycle. See, so we'll be talking about few to say comparisons between RISC and CISC, you know, uh, design. So first we'll be talking about instruction complexity. So it's very simple. Like if you just remember one, you will be able to answer the other. So here the complexity of RISC is simpler and fewer instruction types. The opposite goes for CISC, complex and many instruction types. And instruction execution most complete in a single cycle. Instructions may take multiple cycles. Like I said, RISC is very simple. It has simpler instructions, so it completes within a single cycle, in the sense single clock cycle, and this takes multiple cycles. The code size, it is large, requires multiple instructions for complex tasks. Complex tasks here means like that division, multiplication and stuff. So like more than one instruction is for multiplication or for division, like two register values are stored, and then the value is stored in another register, and then it is fetched and given. So it's kind of a complicated thing, right? So multiple instructions comes there. Like to do one task, you require multiple steps, right? Few systems or processor, they directly, do not require multiple steps. They just finish in one, but here it requires multiple. So the code size is large, requires multiple instructions for complex tasks. Here it is smaller, see, and single instruction can do a smaller task, I mean complex task. So registers, there are many general purpose registers. Just remember this. GP, wow, oh shit. I wrote there. Whatever, it's not a comma, it's P, okay. Many general purpose registers, and here they have only few specialized registers. We'll be talking about them later. Memory access, see, it uses load store architecture. Don't worry, you will be able to remember these words because it comes one of the four major, areas of RISC. And here, memory can process memory directly, or you can say it can access memory directly. You just have to remember process memory directly. Performance, high speed, optimized execution, slower due to microcode execution. You don't have to write too much. If you are a good and bright student, you can write these words for better quality. But if you just want to pass, you can remember high and slow, all the opposite things. So see, there are one, two. It's easy to remember these two. Right? Instruction, complexity and execution. How complex it is? It is simple or complex. Execution, like how much time it's taking, how many cycles. See, code size, large and large, small, multiple, single registers, general purpose and special registers. Memory access uses okay, L load store, or direct performance, high and slow. See the four major design rules of RISC. So this is what I was talking about. Though in the textbook you see it's quite a long thing. They have even one thing about RISC and RISC. The compiler is having more complexity. Here the compiler has no complexity, but the processor is having greater complexity. Understood? Like both are generating code, but the complexity is higher in the opposite, parts of both the design philosophies. We'll see in the notes which I have prepared. You don't have to worry about these notes. These notes have been, what to say, developed, I mean, made, generated from the textbook itself. I have filtered the textbook content and then made this note, so you don't have to worry about the notes. The notes for the further modules are much more better than these modules, okay? So instructions. So the number of instructions, it has reduced number of instruction types. In the sense, it doesn't have multiple instructions. It has a limited set of instructions. So it has reduced number of instructions. See, since it is filtered, it directly wrote the reduced number of instruction types. So you can also mention it has reduced number of instruction types. It has fixed instruction length. Fixed instruction length can help for pipelining. You know, if the length are fixed, then you don't have to worry that it will change during the processing or while executing. It won't change the length. So pipelining is very helpful over there, where you can break into different blocks and then execute it one by one. Then complex operation, example division, is achieved using multiple simple instruction. Like I said, if you have to divide two number, you have to load and store the value of each number. You have to divide, like 6 divided by 2. First 6 will be stored in R1 register 1, and 2 will be loaded in register 2. Then they will perform the division operation, and then the answer is stored in a new variable or updated in the same register. It's just like that. Then talking about pipelines, it is nothing but the instructions are broken down into stages. You have to remember the word stages, okay, and executed in parallel. There's a famous browser. Like let me do by 3 1. Okay, so see, as soon as the first stage is executed, the another instruction which has 3 stages, the first stage will start executing. So now you can see here one more box will come. Okay, at this place, like 3, suppose this is a clock cycle number 3. Here the first stage or last stage of the first instruction, second stage of the second instruction, and first stage of the third instruction, all three are being executed, what to say, parallelly. You understand, right? So that's what they mean to say that it is broken down into stages and executed in parallel. Each stage processes one instruction per cycle for maximum throughput. In the sense, see, each stage processes one instruction per cycle. each stage. See, one instruction. Okay, so in this stage we have multiple instructions. So the only one instruction is being processed under one cycle. So what it does nothing but in the maximizes the throughput. Throughput is nothing but the time taken to to process something like that. We'll study about this again further in the module. No need for micro execution. See, micro execution is used in CISC, unlike CISC processor. We have seen here, right? It's slower due to micro execution. Then registers, we already saw in the comparison. It uses large multiple general purpose register set. Any register can store data or an address. So, see, data is something. I suppose the data of this, suppose is a register and it has a data like 12. See, the data is 12, but the address is something like 1001, like bit numbers, like where the actual thing is. So, for example, the box has books, okay, but the data of the box is nothing but it is having books, but the place it is stored is in storeroom something. So data is something else and address is something else. So it can store data or an address. Okay, and in CISC registers have specific dedicated functions. So they have highlighted both the things over here. One, they have spoken about RISC, and then they have also shown the comparison of CISC. We know that it uses some specialized set of registers, right? See, few specialized registers like that. You can also talk about how many registers are there and all stuff. Then finally, the fourth thing is nothing but load store architecture. So data operations are performed only on registers. So you have to remember what data operations. Okay, so separate load store instructions transfer data between register and memory. So if you know that bus diagram, you will be able to remember that there are that memory things and like few registers and all, how register carry everything perform, and then the everything is updated in the memory, or whenever it requires it is loaded from the memory. It's just like that. So separate load and store instructions transfer data. See, one load is nothing but take collect or like take back the data. I'm taking the data from the memory to perform something, and then once I'm executed the thing, I'm just storing the data. Load is nothing but fetching the data from the memory, and store is nothing but storing the data into the memory. Data operations, that's the data operation, load and store. So if you wonder what are the data operation, load and store, the name itself says, and they are only performed on registers, remember, only on registers. Memory access is slow, so keeping frequently used data in register improves performance. So here, the time taken to access data from the memory is slow. That's how what they do. So many, it has multiple general purpose registers, right? So it just keeps the memory in those registers like cache or something, so that it's easy to access the data from those registers instead of time to time again and again fetching it from the memory itself. So that's what it's saying, memory access is slow, so keeping frequently used data in registers improve performance. So here we are improving the performance by doing what? We're not going back to memory again and again waiting for all the time, because it takes time. So now what you're doing, when a register loads the data, it has that data in it. So frequently used data, not every data but frequently used data is, for example, you might need a data set to get answers. Like for example, ChatGPT is using particular data set from a subject to answer a question, set of questions from a particular subject. So you're just saving that data set with you, like it doesn't have to again and again access the data from the beginning. Instead you can save it in the register like that. So key advantages of RISC: simple design and higher clock speed. CISC processor have adopted RISC principles over time, reducing the difference between. So first thing was RISC. RISC had come long ago, and still RISC is being used. The CISC now what they are doing is they're trying to copy RISC, like so that they improve performance and stuff. But the difference between them is reducing slowly. Then the next topic is introduction. So if I have to mark it, we have completed this, so we'll go to the next topic in the next video. I mean, yeah, next video. Bye bye.